Okay. Yeah. Hello, everyone. While we're waiting for other students, I hope you have scanned the QR code. And also, if you want to check the Google Classroom, I think I just posted this morning uh, some details of what we will do in December, and we will start on um, December 14th. Okay, December 14th. Yeah, December 14th will be the first class of our PBL method. So I hope this week you can select topics. Okay? Maybe I will review some part of it, and then we can start today's course. Okay, I will go back to the notes later. Let me show you first the. Okay, this is what I have been uh, announced this morning. So if you look at the information here, um, so according to what we'll do, let me, okay, maybe I will make it. Okay, okay. So first, the PPL that I mentioned last week, we will be perform that PPL class on December 14th. So December 14th, and we will conduct this PPL until the end of the semester. So how to prepare the class? First, you need to choose topics, okay? And I have some attachment that you can see. It's chapters from the textbook. And what I want to suggest, or the topics that maybe for your reference, is probably around chapter 7, 8, 9, 11, and 12. Because I think I will cover chapter 10 and 6. Chapter 10 I will cover today, and maybe 6 maybe next week. Next week, or maybe yeah, because chapter 6 is not really that uh, really a lot of content. So 7, 8, 9, 11, and 12. So chapter 7 is still a trigonometry. Okay, this chapter 7 is trigonometry. That's but mostly about the analytical trigonometry. Okay. Chapter 8, this is about the polar coordinate. Okay, the polar coordinate. Uh, what's the difference? Polar and then the normal coordinate. Normal coordinate, you know the x and y, right? The polar is you have uh, the coordinate is in radius and angle, r and theta. You can observe and explore. Okay, and chapter 9, this will be about the vectors in 2 dimension, vectors in 3 dimension. Okay, chapter 11, it will be conic section, ellipse, hyperbola, right? Okay. And 12 is sequence and series. Sequence and series. Like maybe you remember the arithmetic sequence, geometric series, okay, arithmetic series, geometric series, okay, and how to sum the series, okay. And what do you need to do? Okay, so you need to explain the topic. Okay? So, for example, because there are, I think, more than 5 students, right? Because this is only 5 topics. So, because you are maybe 10 or 11, I think, the student. So, um, the idea is if you choose one topic, you need to specify what kind of subject for that topic. So, for example, you choose chapter 7 or you choose chapter 8, but inside that chapter, there are several specific things that you might looking at. If you look at the attachment, okay, if you look at the attachment, this is the example for example, this is the sequence and series. Uh, Maybe you can choose arithmetic and geometric, okay, because that is about the sequence, or maybe you can choose mathematical finance or any specific topics from one chapter. Okay. Okay. So okay. Uh, oh, I think I can revise this. Not 7 December. Okay. So let me uh, re-explain what this is about. Okay. So okay, December 14th, we will start the PBL class. What PBL class? What is PBL class? So PBL class means that I need to get involved with students more. So the students need to get involved with the topics. In this case, you need to explain for a short period of time simple topics. Okay. The topics that I can suggest to you is from 7, 8, 9, 11, 12. You need to pick up some subsections of the topics. Okay. For example, the previous one I showed you the sequence and series. You can choose which one you want to explain. Okay. And after that, after you choose the topics, okay, maybe you can choose the topics within this week. Okay, within this week, okay. I will make some announcement for submitting the topics. Okay, you just write what is your topics, and maybe you can also add additional information of your topic. Maybe you want to correlate or you want to find more like sequence series, and then maybe find another related things uh, in technology. Maybe you want to connect with some science and other science such as physics or chemistry. That is also okay. So you can think in a more creative way to do these explanations. Okay. Okay. And what do you need to do? Explain the topic. So you need to make a video first, a short video. I think duration 15-20. If you think it's too long, 10 is also okay. I think 10 is also okay. Okay. Less than 10, that's also fine. Just video, and then I will upload the video, and then I will put in the link into the Google Classroom, so all the students can watch the video before we start the class. Okay. Uh, Please prepare this video before. It's not December 7th. Sorry. I think before December 14th, probably December 12th, December 12th. So I can upload all the video on December 12th, and all the students can watch each other video. Okay. And if you think the time is not really okay for the video, I can extend for a few days, okay, for the video. But I hope on December 14 we can start the class. Okay, start the class. And let me see. On December 14, okay, we will have a short presentation. Okay, short presentation. So I will randomly select the students to explain the topic in the classroom. I'm suggesting you prepare maybe any presentation material, or if you don't need to, that's okay. You can use the board, but that will be difficult to record if you want to have in our YouTube videos. Okay. So if you want, you can prepare maybe some presentation if you have time to make it, and I will maybe use it in the computer, and you can present, and I can also record your presentation. And of course, how about the students who are not arrived yet? The students who are not arrived yet, they will be expected to explain the topic after they arrive, and hopefully after December 21st, you can arrive. You will be arrived at Taiwan Tech. Okay. Okay. So the presentation is actually presenting your previous video. Maybe if you think the video is too short, you can explain more. Okay, you can explain more for a short period of time. And if you have difficulty to explain, like for example, when you explain and then you forget something, that's okay. I will help you. Okay? I will help you. So this is the way that I want to have interactive, and I want to I want the students to be more involved in this activity. This video and then video presentation after we have finished all the students, and I think we will finish around January, first week January. You will have time for weeks, okay, weeks before there will be another report, okay, another report, okay. So after that presentation, that is the video maybe around short period of time. Maybe I will change the durations on your explanation. Maybe it should be shorter so that you don't need to like prepare a long video. Okay. The long video, however, I need you to make it like at the very end of the semester. At the very end of the semester. Uh, uh, I think the final exam around middle week of January. So this will be around that time. We will have also final exam, but the percentage for this report will be higher. Okay, will be higher. So this should be helping you to, at least if you make all the video, explanation video, final report video, uh, you will have high percentage for your score. Okay. And if you make a good video, good explanations, this will be added to your final score also. What is the final report? This final report this is um, actually, the topic is actually up to you, but what I suggest is maybe you can connect or relate to your presentation before. So you take some part of the presentation, you explore another thing, and in more uh, probably you can have more creativity here, and the duration is up to you. You can make it 10, 15, 20, 25, but the conclusion from the video is that you need to summarize what is mathematics used for in the life in our life and you can explore many topics. Okay, and for how the video conduct both of the presentation video and the final report, I have some example here. You can watch later. Okay, you can watch later. You can make it like if you have the time and you have the equipment, you can make a video like my notes. Okay, if you have the time, or you can use the just the board. Okay, just the board, and then maybe you need to help from your friend to take video, and then you make some explanations. That's also okay. Or uh, you may maybe using a paper and using a smartphone here, and then you explain and then writing something on the paper. That's also fine. Okay? As long as the video can be uh, clearly explained. Okay, clearly explained, and I can also see what you are writing. And yeah, I think that's it. Okay, and you may also see this picture 1, 2, 3, 4. This is the chapters and the some specific topics. Okay. But if you think you have another additional topics that related to our chapters here, that's also okay. That's also good, and it's I think you can have more bonus points because you can think some topics that is still related to our chapter. Okay, so this will be again December 14th. Okay, December 14th. So I think I will cover. Okay, because what I suggest to you is chapter 7, 8, 9, 11, and 12. I will cover chapter 6, chapter 10 for this week and next week classes. And yeah, I think that should be sufficient, okay, sufficient for us. And today, actually, I want to start with the chapter 10 for a while. Okay, chapter 10. It's about the linear equation and matrix. And maybe next week, for a short period of time, I will cover chapter 6. It's still trigonometry, but triangle trigonometry. Okay. 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 Maybe any questions first? Any questions first? Maybe from the online students, because you didn't come to the class. So, do you have any questions? Okay, you can check later again and read the whole thing here. And if you need to have some idea or question that you need to discuss, please let me know. So what you need to do before all of this is this week, give me your topics. Okay, give me your topics. I will prepare another posting related to topics. You need to submit your topics on that post. Okay. Okay. So that will be our PBL class. Okay, so hopefully we can have a good PBL class. Okay. And of course, I will try um, to help you during the presentation and also to help our class to finish the chapters. Okay. If we have like maybe you are explaining chapter 8 for several subsections, but we still need more explanations, I will make myself, I will make another video to add, okay, to add your explanation. That's the okay. That's the okay. If we still like maybe in the class, we don't have much time to explain all, okay, so I will have my own video. I will make another video to add, okay. Okay, so I think we are 4 and 6, so it's around 10, and I think there's one that's still on the way online. So we have, I think, 11 students. Yeah, 11 students. And since we are, let's see, 11, 5, 14, 6, 6. Okay, I think enough. Okay, I think the time should be enough. So we will have from December 14th until the first week of January all the PBL classes, okay, all PBL classes. Of course, I will also teach. Okay, so after your presentation, I will add another thing to add, uh, and if we still have something to discuss, but our time is not enough in class, I will add another video for you to have. Okay. Okay. So yeah, that's it. Okay. Any questions from the classroom? Any questions? Okay. And when you are doing your presentations, please you need you don't need to be uh, nervous or panic. Okay. Of course, I will help you to to get your presentation correct. Yes, Andres. Uh, for the final report, it could be any topic related to math, but for the presentation in class, uh, yeah, it can also be related to math, but I suggest to to give any topic that is, for example, we already have learned the fundamentals of math, the functions, the polynomials, the exponent and logarithm. I hope uh, aside from those topics, okay. But if you have any topics related to that, but I still haven't covered yet, you can submit your topic. So submit the topics first, and let discuss for a moment. Okay, so you can submit first, and then we can discuss. Okay. Okay. Let's see now is um, chapter 10. Okay, I hope you already scanned the QR code. If you haven't, you can scan now. Okay. Okay, the chapter for today, this is about chapter 10. This is about the system and system of equations and inequalities. Okay, we start with system of linear equations. Okay, this is our first uh, introduction. Okay. Okay. Now first, okay, uh, linear equation is something very basic that you may have learned previously on your maybe junior high, okay, junior high school. Um, for example, you need to solve this. So x minus y equal 5, and you have x plus 4y equal 7. Okay. So before we look on the solutions on what this is, uh, this linear equation, we can check the line, the graph. Okay. 'Let me move this a little bit there. Okay, so I think I can make first this will be x plus 4y equals 7, and another will be 2x minus y equals 5. This will be 5, and I think this will be around here. Okay, so this will be x at 2x minus y equals 5. Okay, now to introduce you to our linear equations is first look at the intersection. This intersection here. This is probably 31.31. Okay. So the intersection, okay, 31 is the intersection. And since the, the intersection means that this point 3 and 1 here, x equal 3 and y equal 1, will be on both lines, right? The lines of the red lines and blue lines. So in other words, okay, this will be our solutions. Okay? If you look at the graph, because it has certainly at this point here, uh, then if we have this kind of equation, 2x minus y equals 5 and x plus 4y equals 7, we know that our intersection here will be our solution. So if we check the x equal 3, y equal 1, and that will be true. Okay, it's true, and also 3 plus 4 is 7, also true. Okay. Okay. So first we think on visuals, and then when we are looking at the visuals, we know the intersection point. That will be our solution. Okay. Now, of course, I think you also have learned that you may solve the this linear equation. Okay. If you look at, you have 2x, you may multiply the second one with 2, so that if you subtract, these 2x can be canceled and you can evaluate the y, and from that y value you can evaluate the x. Okay. We call that the eliminations method. Or you can substitute 2x minus y equal 5, and you can substitute becomes y equal 5 over 2x minus 5 over 2x, and you can use that in the second equation, and you have the uh, the solutions. Okay, so first, that the first thing, maybe I will start with substitutions first. Okay, we can start with substitutions. Maybe start with x plus 4y equals 7. Maybe start with x 7 minus 4y, and then 2, 7 minus 4y minus y equals 5. And we can solve this. So we can have negative 9y. So negative 14 and 5. This will be negative 9, right? And y will be 1. So x will be 7 minus 4 is 3. Okay. So you can also get this solutions correct with the substitution method. Okay. Okay. What I want to show you here, the substitutions, elimination in the linear equation is actually a powerful method, and still in the modern algorithm, when you learn the linear algebra in, I'm not sure whether you will learn or not, but that's the key for for some programming. Okay, actually, so from some programming. Okay, like every mathematical problem, when you think on finding solutions, actually they think in an algorithm that is based on mathematic structure. So uh, this part here, although it's really simple, but it's very powerful. It's very powerful. Okay, aside from substitutions, we can also have the eliminations that I have mentioned before. Let me start with the elimination here. So 2x minus y equals 5, x plus 4y is 7. Okay, to start with eliminations, we think of the constant, okay, of the x and constant of the y. Okay, we need to eliminate either x or y. Okay, we can choose based on our preference. Let's say we try to eliminate x. Okay, so we may multiply this by 2, and then we subtract these equations. Or let me write this become 2x plus 8y and 14. Let's start to minus. This will be negative 9y, and this will be negative 9, right? And y will be equal 1. We can also multiply by 4, so 8x minus 4y, 20, and x plus 4y, 7, but we need to just plus this. So 9x is 27, so x is equal to 3. Okay. Okay. This whole thing we can conclude or summarize. This is we call linear system with one solution. This is what the terms is actually about. Okay. Okay, let me give you another example. Okay, so you can have more. And for you, those of you who not really uh, understand this part before, we can have more discussion. So solve the system 3x minus y equal 0 and 5x plus 2y equal 22. Okay, you can solve. I will give you the graph. Okay. So if you graph correctly, we may get that graphics, and you can solve this using substitutions or eliminations. We can start with the maybe these eliminations multiplied by 2, and then we plus this. So this will be 11x, okay, equal 22, and x will be 2. And since x equal 2, we can also use the substitution to check. That is y is actually 6. And you can use elimination and substitution in any way you want, okay, because that method is fit for each other. Okay. So this is linear system with one solution. Okay, one solution. So you have perfectly one solution uh, on the graph, right? Okay, another example, and then we can also see what kind of system is it. So 8x minus 2y equal 5, negative 12x plus 3y equals 7. Okay, solve the equation, solve the system. Okay, can you try solve the system for this x and y? What do you think about the solution? Okay, what do you think about the solution? What is x and y? So the conclusion is what? Okay, this. Okay, this is what we call the system will be inconsistent. First, that okay? The system will be inconsistent. Okay? So if we try to work out, maybe this will be multiplied by 3. This will be multiplied by 2. So you will have 24x, and this will be negative 24x, 3, okay, 2, 6, 2, 14. When we plus this, okay, this will be resulting 0, which is not 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 logic at all, right? We call this the system is inconsistent. And the uh, the linear system has no solution. When we think also, if you want to look at how the system is. Okay. 8x 5/8. That's maybe here 1, 1, 3. So maybe this. This will be 8x minus 2y equal 5. And should be around I think it should be around that point. This will be negative 12x plus 0y equals 7. If you look at the graph, okay, when you have no solutions, there will be no intersection between the graphs. Okay, there will be no solutions, and we can say the linear system has no solution. Okay, and we can also say the system is inconsistent. Okay, okay, that is the. So this is we call a linear system with no solution. Okay. Okay. Another one, if we have 3x minus 6y, 4x minus 8y. Okay, what this is about. Okay, can you solve this? And what's the difference between this and the previous one? What is the difference? Okay, what's the difference between this and the previous one? Same. Okay. The system is inconsistent, but the conclusion will be different. Okay. If you look here, the system. Okay. If we try to solve, okay, if we maybe make some elimination, this is multiplied by 4, multiplied by 3. This will be 12x minus 24y. This is 12x. So if you see and you try to solve this, it will be 0, 0, right? The previous one, 0 with some number, right? So if you see 0, 0, which means that you can have any possible x and y. You can have more. Okay? You can have more. Okay, so what we can do now, if we want to solve this and look at how the line will work, okay, let me just write here. The 6y is 3x minus 12. So y is half x minus 2, right? And if let let x equal t, and t will be any real number, we can write the y as half t minus 2. So I'm using t to have more detail and description on how this is going to work. So this will be 1, 2, 1, 2, 4. And if you look here, this is 1t equal 4. This is 1t equal 1. So we can write solution. We can write for this case, if we let x equal t, will be t and half t minus 2. But of course, if you look at xy solutions here, this is what we call the linear system with infinitely many solutions. So what does it mean and why we can relate to this t? Okay, so as long as you have this slope, okay, you can have as many t as you want, like from t equal -1, 0, 1, 2, 3, 4, and then you may have like ordered pair of the solution, and there will be infinitely many solutions, infinitely many t, right? So you can have all solutions that is in the slope, right? Okay. So three cases that might happen in the linear equation: one solution, no solutions, and infinitely many solutions. Okay. This will be 0, 0. Okay. Of course, with this model of linear equations, you can have many system modeling from physics, and then mixture in chemistry, right? You can also have in finance also within this linear equation. And I think I will just skip that models uh, and go through the second part of chapter 10. Okay. So the first part is just introductions, and I think you already have familiar. The important thing, just the three conditions: one solution, no solution, and infinitely many solutions. Okay. The next part is uh, system of linear equation in several variables. So we can write the system as like that. Okay. Or A1, A2, AN, and C all is real numbers. And X1, X2, this will be our variables. Okay. So we have done the system with two variables, x, y. We may have x, y, z. So let's try to look at the x, y, z. So if we look at the x minus 2y minus z equal 1, and minus x plus 3y plus 3z equal 4, 2x minus 3y plus c equal 10. And compare with the, we can solve this. If you look at the number constant, you can eliminate the constant here. Okay. So we can try to look at this and look at this x and y. We can eliminate, right? We can eliminate this, right? Either the first one or the second one, you need to choose. But the form you can write in a, we call the triangular form. Okay, so this is system of linear equation, and we can write in a triangular form. X minus 2y minus c. This is y plus c, and z equals 3. Okay. So if you try to work out here, either you find z or x or y, you can write that in the in this triangular form. So when you find one variable, x, y, or z, for example, this is z, you can define z equal 3. Then to find y, you just substitute here, and you find y. You have y and z. You substitute to the last part. So this is another way to look at and how to solve. Okay, in a convenient process. Okay. So instead of writing some messy calculation that you have, you can write in a really good way that you can have more detailed descriptions approach when you get all three variables at the very end. Okay. So this is not just about how to find the solution, but how to make the solutions step by step in effective way. Okay. Because sometimes when you do some calculations, you do some calculation here, really messy, and then if you are not really paying attention to the equation here, you will maybe going circle around and you don't really find the solutions sometimes. Okay, but if you write in, for example, using the triangular form here, you may have really a good process and an effective written formula. Okay, so that's one way to look at. And we can see the solution will be, this will be 2 minus 1 and 3. So usually this is how we write the solutions. This is x, y, z. So the solution okay. Now another way to look at this example here is by using we call the Gaussian elimination. Okay, this is some one method that is really effective. Okay. First, okay, I will write this operations. that yield an equivalent system. So first, add non-zero multiple of one equation to another. To multiply an equation by non-zero constant. And three, you can interchange the positions of the equations. The whole process when and then you can use the back to back substitution or just substitution still. Each variable. This is called the Gaussian elimination. Okay, let me give you an example on how we can solve this uh, system using the Gaussian eliminations. Okay, because when we are in this chapter, in the section here, we are not only talking about x, y, because if we look at the previous example, 2x minus y 5, 3x plus of something y 7, we try substitution, we try eliminations, and we can have some calculations, and then we can get the solution x and y, right? But imagine when you have 5 variables, 6 variables, 7 variables, how to solve that, and how and how to make the solutions, the process in really effective, okay? And to make the solution faster. Okay, so let me go through the Gaussian elimination. Okay, okay, so solving a system, start with three equations. Okay, three equations and three variables. Okay, and then let's say we have this three system, okay? Three equations, three variables, x, y, z, right? Okay, so first we may look at the variables that have the same constant. Okay, so for example, we start with the equation 1 and 2. Let's say this is equation 1, equations 2, and equation 3. I'll start with the equation 1 and 2. this will be minus to take out the x. So this will be negative 4y plus 4z equal negative 12. But I want this to be in this form. Okay. So I will have the 4y minus 4z 12 equal 12. Okay. Okay. And then from here I can have, let me write the equation 1, and then this will be my equations 2, and let me write the equation 2 inside this. And this is still the equation 3. Okay, so this will be equation 1, equation 2, equation 3. Okay, the same way, now we need to remove the x terms from the third equation and one equation. The first and third equation. Okay, so at 1 and 3, this will be 3x minus 6y plus 9z equal 3. So this is equation 1 multiplied by 3. And 3x plus 2y minus 5z. This will be subtract. Okay. So this will be negative 8y plus 9 plus 5. It should be plus 14z. And it's equals 0. So I will write in positive y here. Okay. So my new equations we have, okay, well, our solutions will be and I will change this third equation with the new equation that we just found before. Okay. So we have this now 1, 2, and 3. Okay. Okay. Now we can solve this y and z, right? If we can solve this y and z, we can multiply this with 2 so that we can eliminate y. So we can 2 and 3. We can have 8y this will be 6z. Sorry, it should be 24. Plus this is 24. So z is 4. So we can write this. Okay. And now look at this form here. This is the triangular form. Okay. So what's the point? And what's the point for doing all of this? Okay. Maybe you seem saying like, oh, maybe it's easy to calculate this and that. Okay. Why this method is really efficient? Look here. Okay. You have three equations, right? You have three equations. You have three equations. You can exchange one equations from this tree into another form that you can think of. Maybe you can use elimination with this and this, or this and this. Try eliminate y, try eliminate x, and those equations can be exchanged with this one line part. Okay, one line here you can be exchanged with another equations, and you get like maybe several steps. Okay, the shorter way you make, the faster you will get the answer. if you start without any directions, sometimes students in mathematics, in any math course, in calculus, in engineering of math, in any math related course, when they were given the questions, they will start out not really having purpose or directions in their calculations. They just want to calculate blah 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 blah. They write in a full one paper, but they don't get the answer, and maybe the professor will give 0 because their answer is not really directed. Okay, in the linear equation here, you'll be trained and think to to go step by step, slowly but sure. But and it's actually faster. It's actually faster. Okay, this is just first method. The other method is still the Gaussian method, but with different form, and it will be I think it will be faster than this one. Okay, because it still has this plus minus, and it's still like an equation here, right? We will use matrix. That will be an advanced method to solve the linear problem. Okay, so this is called the Gaussian elimination. Okay. Okay, so this is a system of 3 equations in 3 variables. Okay, how about the graphs? Okay, the graphs in 3 equation and 3 variables. What will be? So let me make it to you. Okay, what will we have? Okay, I will write the summary first. Okay, so number of solutions. This is also based on the previous section. So solutions of a linear system. So first, as you know, the system has exactly one solution. System has no solution. And system has infinitely many solutions. Okay, so if you have the three variables, 3 equations, we will have, let me write this. Oh, let me draw directly. So maybe this is the, okay. So if you have 3 variables, you will have a plane. Okay, you have a plane. Okay. Okay, that's the first one. And also, okay. So this is the system of one solutions. So there will be intersect at this point in the middle. Okay, so imagine you have like a plane. You have like a 3 plane equation here. So first is this square here. So the first is the square with the pink curve. Okay, And the second one is the blue curve that is vertical. The third one is the red curve. Okay? It will intersect at exactly 1 point. If I want to make the color, maybe is it. Okay, if you want to make it more clear. Okay. Okay. Another example is this. Okay. So this is one solution. This is no point in common. So no solution. And let me maybe make it a little bit smaller. The third one, okay. It should be straight line here, so yeah, it's not really good here. It should be like this. It should be like that. Should be like that. Okay, so this plane is intersect in many points. Okay, so this is the intersection. This is we call intersect at more than one point. So this is have many solutions or infinitely many solutions. Okay. That is if we want to draw in a 3-dimension. Okay. We call the no solutions also with the, it's called also the inconsistent. And the many solution we call dependent. If you remember, no solution is when you have when you calculate, you have something 0 with and then equal with that the number constant. This is no solution. Okay. If you end up with 0 equals 0, that means it's infinitely many solutions. Okay. Okay, that's the it's more about the introduction of the linear equations. Okay. Okay, and system equations. Okay, the third part, this is called the matrices and system of linear equations. Okay, so before we start, I would like to know from all of you uh, who hasn't studied, or maybe the curriculum on your high school doesn't involve any matrices. So you guys have learned matrices before? Okay. For the online students, do you guys learn the matrices before in high school? Okay. Uh, because from my experience, some international students might have not really learned about the matrices. In the classroom, I think all of you already learned matrices before, right? Okay. So let me do some review. Okay, let's say we have a linear system. So linear system, and augmented matrix. So we can write this in terms of 2, -1, 5, 1, 4, 7. the first 2 and 1 here is our x, the column and row. So this will be y. So the first column is x, the second column is y. And the equations, we can exchange this into augmented matrix. Okay? So we can represent any linear system in a matrix form. Okay? And by definitions, a matrix is, if we have this, we can write the positions of each singular number or singular constant in the matrix with 1, 1 like that for the top left part, and then 2, 1. It's symbols for its row and column. Okay? 3, 1, and so on. This is M1. This is 1, 2, 1, 3, and this will be 1, N. Okay? And then we have A, M, N. So this is M and matrix. So the column and row of matrix. So this is composed of, it's a rectangular of array, or rectangular array of numbers, probably better, array of numbers with M row and N column. The dimensions of matrix is based on the row and column of the M and N. So if we have just a random number 2, so this will be 2, 3 dimension matrix. If you have just 1, we can have 1 also, like 1, 3, 1, 0. This will be 1, 4, okay, dimension of matrix. And how to solve is basically the principle similar with the previous one, but it will be much effective. Okay. Let me show you on the way here. It's called the elementary row operations. And basically the same as what we have in Gaussian elimination. So add multiple of one row to another, multiply row by a non-zero constant. And you can also interchange 2 rows. Okay, let me give you example. So x minus y plus 3z equal 4. X plus 2y minus 2z equal 10. And then 3x minus y plus 5z equal 14. Okay. First, we can rewrite this into our matrix form. So 1, negative 1, 3, 4, 1, 2, negative 2, 10, 3, negative 1, 5, and 14. Okay, what's the idea behind this method here? So if you look the instructions, you can add multiple of one row to another. So you can add, and then in another row you can rewrite your new equation as we did in the form of equation previously, right? So for example, you want to make this first row minus second row, okay? Or you want to have second row minus the first row to eliminate this one here. Okay, when you do that, you can rewrite one equation here between 1 or 2 with the new equations. Okay, for example, you want to rewrite here, and it will be making a new row. So for example, I want to maybe change the second row. Okay, so I will write this is 1, and then I will write R2 minus R1. Okay, so this will be 0. This will be 2 minus 1, 2 minus minus 1, so it should be 3 minus 2 minus 3 minus 5, 10 minus 4 is 6. Okay, so now you have 0, 3 minus 5, 6. Okay, the third row, I want to eliminate the 3 here. So I will minus this 3 with either 1 or 2 because it's the same 1, 1. So I will minus 3 minus maybe second, and then multiply by 3. Okay, so I can write this in the another instruction here. The row 3 minus maybe row 2, 3 row 2. Okay, so 3 minus 3 is 0, minus 1 minus 6 it's minus 7, 5 minus 6. Okay, so it will be 11, and then 14 minus 30, it will be minus 16. Okay, notice that now I have 0, 0 in this part, right? So the idea for this um, eliminations or the elementary row operation is making this 0, 0, 0. Okay. So when we have this 0, 0, 0, we will get exactly one solution here, right? And then you can exactly got all the solutions. Okay. And if you look at that and imagine how it will be, you can imagine that if we have this, if we have this kind of form, 1, 1, 1, and then a constant here, we will have exactly solution for z, solution for y, solution for x. Okay. So basically, if you look here, the row operations, you can do many things. Okay, you can multiply this with some numbers, minus, plus with other row, and then exchange that number, and you can have many ways to solve. Okay, and the fastest method or the fastest thinking is to choose correct row, okay, and then find how to make it. This is 0, 0, and 0. Okay. To make it 0, you can think any maybe from 7 here. So multiply the 7, but I think that will be getting 1 here. So I think just these two, row 2 and row 3, making some solutions there. And I think we will still get the correct answer. I will continue this part tomorrow. So we will end up until this part. We will have more examples, maybe 2 or 3 examples for tomorrow, and how you can also try by yourself on using these elementary row operations. Okay. Okay. Because I think I'm not sure whether you will learn in engineering of math or not, but when I was still a student, I remember I'm using this elementary operation in other math courses, engineering of math. Okay, yeah, I think still important. Okay, now to end this lecture, I prepared the feedback for your uh, for your it's chapter 10. So I hope you guys can prepare some paper. I think I just prepare 2 questions for you. Okay. Okay, if you ready in, let's start the okay. Okay, let's start. 3, 2, 1. Let's start from. So you need to write the solution in X, Y, Z using comma without space. Okay. If there is no solution, write no solutions. 2 minutes. I hope enough. Okay, 2 minutes. I hope enough. Yeah, if the time is too short, and I think I can take that as reference for next questions. Okay, 45 seconds. I hope you guys get the answer. If not, that's okay. Okay, 30 seconds. 25. 20. 15, 10, okay, 5, 3, 2, 1. Yeah, I want to know who answered the the other part. Do you answer this? No. So I would like to know who answered that part. Okay. 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 Get ready. One more question. Okay. 12, 11. Okay. 6, 5, 4. Okay. Okay. Good. Okay. Congratulations, Scarlett. You win the game. And that will be the end of our lecture. Uh, check the Google Classroom later to maybe you have more questions about the PBL class that we will start on December. We will continue the system of equations tomorrow, and hopefully we can have some example. And still next week, we still have some part on matrix that we need to cover. And maybe next week after that, uh, we can have some of the chapter 6 and maybe a little bit chapter 7. Okay, so that will be the lecture for today. Thank you for coming. See you tomorrow. Yeah, see you tomorrow. You're welcome, Scarlett. I hope to see you soon.